The basic idea for these problems today is to try and simplify them using substitution. And what we're going to do for each problem is we're going to find an inside function. Just like when we did chain rule, we had functions inside of other functions. And our inside function we're going to set equal to u. And that's going to allow us to try and simplify what our antiderivative looks like, what the integral is, to a point where we can do the antiderivative. So u is going to be our inside function. Let's look at number 1. We have square root of 5x plus 7. That of tells us we've got another function on the inside. Square root is the outside function of 5x plus 7. So our inside function is 5x plus 7. So we're going to end up substituting u in for 5x plus 7. Now, if we do that and that's it, we run into a problem because right now we have antiderivative of square root of u dx. Remember the other day, a lot of people were asking, what's up with that dx? Do we have to do the antiderivative of that? Why is that there? Remember, it tells us what we're doing the antiderivative in terms of, which variable we're dealing with. These variables have to match up in order to do the antiderivative. This one, obviously, is u. This is dx. They're not matching up. These both have to be the same. So we can't just change this part into u, but this whole integral has to be rewritten in terms of u. So the way that we do that is we need to look at what's the derivative of u. All right, so derivative of u would be like du dx. And if we look at the derivative of this, it's a pretty simple one. Derivative of that is just 5. Now, du dx, kind of like we did up here, actually we didn't do it on this one, but we've done before, kind of with antiderivatives yesterday, we can go ahead and multiply both sides by dx. So du equals 5 dx. Now our goal is to write this whole integral in terms of u. So basically we need to have like a du at the end instead of dx. Well, this is the key to doing that. Right here it says that 5 times dx is going to be equal to du. Well, we've got a dx in here, but we don't have a 5 that's being multiplied by it. So that's what we need. We need to have dx times 5 in order to make the switch from dx to du. So what we're going to do is multiply the inside of the integral by 5. Just like anything in mathematics, we can't just go around multiplying, adding, doing whatever we want and not keeping things balanced, because multiplying by 5 changes what this whole thing is equal to. We don't want to do that. We need to keep things balanced. So to kind of balance out multiplying by 5, what we're going to do on the outside of the integral is multiply by the reciprocal. If we multiply by 5 and 1/5, well, multiplying by 5 and 1/5 is just the same as multiplying by 1. So it's not really changing what this whole integral is equal to. It's just giving it a facelift. It's changing what it looks like. Right? Everything's still the same underneath, just looks differently. So if we multiply by 5, and we get this 1/5 on the outside, this 5 times dx, remember, that's equal to du. So instead of square root of u dx, we're replacing that 5 dx with du. Now this is all in terms of u. This is something we can do the antiderivative of. This is like 1/5 times the antiderivative of u to the 1/2 du. Right? Remember, these have to match up in order to be able to do the antiderivative. So this 1/5 is staying outside in front. U to the 1/2, we're going to have to add 1 to the exponent. So we get u to the 3/2 times the reciprocal of that. And don't forget plus c. So we end up with 2/15 times u to the 3/2 plus c. Well, at this point, we need to go ahead and substitute u back in. Right, we started off in terms of x. Our answer needs to be in terms of x. We can just put 5x plus 7 back in the place of u. So our antiderivative is 2/15 times 5x plus 7 to the 3 halves plus c. I'm not going to do it here, but just like before, we can always check our answer here just by taking the derivative of this answer. If we take the derivative of that, we should end up with the same thing we started with. Bring the 3 halves out in front, subtract 1 from the exponent, multiply by the derivative of the inside. All the fraction stuff cancels out. We're left with 5x plus 7 to the 1/2, or the square root of 5x plus 7.